Okay, now let's look at Ohm's law. So we've talked about voltage, we've talked about current, and we've talked about resistance. And those are the three main elements of a circuit, at least a basic circuit. And so we want an equation that will relate these three, right? We know the higher the potential difference, the more current we can get in a circuit. We know the higher the resistance, the less current we get in a circuit. So in other words, current's proportional to voltage and inversely proportional to resistance. So what do we get? We get this. Current is equal to voltage divided by resistance. So if you double the voltage or potential difference across some wire, you'll double the current. If you double the resistance, you'll halve the current, right? If you double both the voltage and the resistance, then the current will not change. Now, this isn't the usual way that Ohm's law is written out. It's written out this way pretty much for the same reason that your book introduced Newton's law as acceleration equals force over mass, as opposed to force equals mass times acceleration. We can control the current by directly affecting voltage and resistance, right? We can choose what batteries in our circuit, we can choose how many resistors are in our circuit, and by doing that we can regulate current. But we can't just choose to have 5 amps of current. We can choose the correct voltage and resistance in order to get that. Yes. So if we look at this paint document here, I've written out Ohm's law as it's traditionally represented, which is V equals IR. So voltage equals current times resistance. Of course, you just divide the resistance on both sides, and you get I equals V over R, which is what we showed before. I should clarify, I represents current. We use the capital I for current, R for resistance, and V for voltage. So Ohm's law is the leading equation when it comes to circuits, right? We need to be able to relate or figure out how much voltage we need to provide to get the current we need, right? Different electrical equipment have different required currents, and we need to, and based on how they're designed, they'll have some sort of resistance, and so Ohm's law can help us figure out how to relate all that. Yeah. So next up, we got alternating current and versus direct currents. We'll look at that in the next video.